So this topic, we're going to talk about foundations for AI, ML, convergence of that with HPC. Yeah, there we go. That's the one. Your photo's right there. Photo's up there.
That looks good.
That kind of looks like you. All right.
Yeah, guilty.
So we'll do a short intro, right? So Ian Pegler there from NVIDIA. Welcome. Thank you so much. He's the head of global business development for CAE. We have Tony from Ampere, head of AI business development. And then David, last but not least, segment director for the HPC team at ARM. Duncan Ng from Vultr, not Vultr, director of solutions engineering. So welcome our panelists. So I'm going to ask a 30-second, a little bit more about you, and then your favorite dad joke or quote.
Yeah,
and then we'll get going.
Yeah. So I'll keep it brief. A little bit more about me. I guess I spent my career mainly as a CFD engineer over the years. So it's kind of interesting coming to NVIDIA with that background. So I feel like I give a kind of a unique perspective from a CFD user. So it's been definitely exciting the last few years looking at like GPU acceleration. I'm based in Chicago, even though I've not got a native Chicago accent, as you can probably tell. I think of a quote, and every time I think of a quote, I just think of quotes from my dad, which just aren't repeatable anywhere. So I'll think of a quote from one of my old bosses. Actually, she was coming back to, I think it was mentioned earlier, this focus on customers, and she was always talking about put yourself in the customer's shoes. And it's kind of like a simple quote, but every day I try and think about that, because so many times, especially working in large organizations, you can kind of lose track and get kind of wrapped up in the dogma of the company you work for. But sort of stepping back and thinking, if I was actually a customer, would I actually do this? Does this actually make sense? And that's just having that thought process every day definitely points you in the right direction.
Awesome. Customer centricity. Huh? Thank you, Ian. Tony, short intro and favorite quote or dad joke?
I'll give one of each really quick. But Tony Rigoni, I'm the head of AI business development at Ampere. Been here about a year. Before that, I was doing a lot of, I was at a company as another startup doing autonomous vehicles, AI and everything around that for, self-driving cars, robotics and all that. Previous to that, I did IoT for Cisco for many years, running their go-to-market and everything for Cisco products. And then 20 years before that, a lot of industrial automation, computer vision, robotics, and everything. So favorite quote would be actually, I thought about this, and it's one I use around all the time. It's for my kids, actually, when they were young, they're teenagers now, but they used to say, hey, how's your day going? And they go, it's the best day ever. So I always say, it's best day ever all the time, but I try to make every day kind of like that. I think about that every single day. And, no matter how bad of a day you're having, I can remember that and see that, and the kids still say it today. But best, I'm going to say my favorite dad joke, AI joke. So why did so I have an AI guy, so why did the AI go on a diet? Because it ate too many bites.
All right, top that, David.
Wow, that's tough. So, yeah, a little bit about myself. David Lecomber.
We're getting a little bit more intimate now.
Yeah, that's interesting. Yeah. I spent the first 15 years of my professional life developing tools for HPC developers. And for the last 7, I've been working at ARM, getting the world of HPC, ready for ARM, really. We've been working on developer tools, compilers, libraries, working with people who are in this fantastic world of HPC to get their software running on ARM, and then working with partners who are developing the silicon and finally deploying deploying ARM silicon to do some amazing things in HPC. That's why I love working with HPC. It's the kind of amazing things that people do. And then to a favorite quote, I think, be yourself. Everyone else is already taken. But you Oscar Wilde.
Hey. That's strong. Yeah.
Hi, I'm Duncan Ng. Started my career kind of in the telecom space as a network engineer. Somehow these bytes have to get from server to server, and lucky enough to kind of enter the HPC space, helping build a top 500 supercomputer at the University of Southern California way back in the day. Been with Vultr a little while now, and really enjoying kind of bringing, what we just talked about at the end of the last panel, HPC in the cloud. It's one of the things that we've really enjoyed kind of working together with Rescale. How do we go ahead and bring this and continue to democratize access to this type of power, to more and more people as data sets are only exponentially growing. We've got to bring that same power to be able to handle all of that for more and more use cases. In terms of, I went with dad joke, especially if I'm the last one, keeping everyone from the bar. So what do you call a fake dad? A faux pas.
Oh, yeah. Wow. Some strong quotes and jokes today in this panel. Awesome. So let's kind of jump right in about digital twin, obviously fluffy term, right? But generally speaking, it's agreed as a way of virtually modeling a physical object and its performance, sometimes with simulation to better kind of understand how we can improve the operations of the product. And it's expected to be a really huge market growing very quickly over the next couple of years. What are you guys seeing? How would you rate this digital twin? Is it all hype? Is it very real? And you have some customer stories you're eager to share, or somewhere in between?
I can start for sure. I mean, I feel the term's been around for a long time, and when I go and visit customers, sometimes when you say the word digital twin, I can almost see the eyes start to roll. And so many people are out there talking about digital twins, right? I mean, I don't know anybody that hasn't got a digital twin somewhere in some sales deck about digital twin. So I think one of the challenges has been the term has become synonymous with slideware of digital twin, and then there's a very complicated PowerPoint graphic that someone's made of lots of arrows going to different places, which is fine, but then it's a shame because there is, I think, a lot of real benefit in it. And one of the first things when I came to NVIDIA was in the office, and by the way, if you ever get a chance to go to the office, it's pretty cool.
It's beautiful, by the way. I'm always amazed how beautiful everything is at NVIDIA.
They've got this demo center, so you can go around and it sees the latest technology. And they had this thing where they had a digital twin, and it was of a Lowe's store. And they had a video of walking through this store next to a digital twin of the store at the same time. And I can be honest, I could not tell the difference between the two. I couldn't tell you which one was the virtual one and which was the video. And so the power of some of those models now and how the hardware can enable that is pretty amazing. And, there's plenty of other examples of how you can take the data and actually really improve your products. I mean, even in NVIDIA, right, we've got a whole bunch of data that comes in from how people use our products, and we use that to dictate what we do moving forward. I mean, there's so much you can do with it, but I think it's kind of taking that step from just the PowerPoint and actually start trying to do some stuff, right? And getting on with it, right? I mean, that's a big challenge, I think, is there's not some magic solution that you can buy off the shelf that's going to be your digital twin. You have to kind of make those steps.
You think it's very real?
Yeah.
From what you're
Yeah.
Tony?
My take on it, digital twin, like you said, it's been around for years, and I think people talked about it too much in the past. And in the past, the issue has been, I really should take it off now because the computational power and stuff to really do it properly really wasn't there before. People try to do it and everything, and the problem was before, you got limited data sets, so it was good, but it was inaccurate a lot of times in digital twins. Now, we gather so much more data now, collect so much more data, and with the computational power we have now, we can basically do a more realistic version, and that's going to help us in the future like this. So I do see, it's been talking for a long time, I do see the acceleration traction starting to take off now more so in the future.
Okay. David?
It's early days. Yeah, it really is early days. And I think the best is yet to come, of course, but there's many areas who are doing it. Maybe they don't call it digital twins, depends on how advanced their PowerPoints are at that point. But, thinking of weather for decades, numerical weather prediction. It's been taking in data. It's a similar. I mean, what's the point of making a forecast if you don't know what the starting conditions are? What would it come up with? The same forecast every day, perhaps. But you take your ingest all this stuff.
All of weather prediction is actually just a big digital twin of the Earth. You could argue that. Yeah.
And over the years, it's got more and more accurate. What they're predicting, the accuracy of a 3-day forecast now is of a 7-day forecast now is probably the accuracy of a 3-day forecast a decade or so ago. And there's data coming out everywhere. Every time a plane takes off, it's sending back pressure data into the weather and climate community. There's the satellites up there. There's buoys in the ocean going up and down. So that's been, I think, one of probably, I think that's a really great example of a digital twin that's been around for a long time. We see it in so
But
many
beyond that,
areas,
it's pretty
but
nascent.
they didn't call it a digital twin.
Yeah,
right?
no, so some marketing guy had to come up with it. Yeah.
Or maybe Formula One, all the sensor data on a car every time it's going around. My God, the amount of data that's generated there. And then they're like, oh, has that team pitted their car yet? Have they changed it? What happens if we pit our car now and fuel it then? And it's race winning, but it's kind of like a digital twin of the race.
Yeah.
But they probably don't call it a digital twin.
Yeah. Duncan?
I think the most interesting thing, kind of like Ian and Tony talked about, is as the amount of data really has improved, the complexity of the systems that we're able to model has improved. I think manufacturing is the easiest place to kind of see this develop. Kind of 20, 25 years ago, Boeing said, hey, we're going to build 777, without paper drawings. People were like, are you nuts? And then to see kind of 20 years later, Facebook and other, structural design, architectural engineering firms talk about doing BIM design for data centers, and then now what we're seeing today, being able to simulate a full working factory, from the machine that builds the machine, that's really kind of driving, and really showing the horizon of where we're getting with being able to model these digital twin environments.
How does HPC and ML and digital twin combine to do something new and different? I mean, you might argue, David, weather simulation's always been HPC and maybe more ML in it, but like more broadly speaking across industries. Right? Sometimes people think digital twin is data coming in, I see stuff, but how do you integrate simulation and prediction? Like, what are some use cases you guys can think of that are pretty exciting on that front?
Yeah, I mean, I think simulation is key because you need to be able to predict the physical world, right? That's the key thing. If you want a digital twin, you need to be able to predict the physical performance of what's happening. So simulation plays a key role in that. And obviously with machine learning type approaches, then that has the ability to potentially speed up that whole process, right? Make those digital twins more instantaneous. Yeah. But there's still a long way to go when it comes to AI, when it comes to simulating what would be traditional CAE, right? We're still in the early days of those applications.
You're talking about AI physics combined with real-time data coming in to...
You're just using AI as a surrogate for a traditional CAE model, right? Right. We're seeing some interesting early work, but it's still very much, there's a lot of work to understand, what approaches make most sense, what are most efficient. As far as simulation and big data, I mean, I think one of the most interesting areas is actually agriculture. When you look at like the issues that we're going to have trying to feed the population, then we need to get a lot better and more efficient at growing food. And I think the combination of like weather forecasting, data coming in from, even each individual plant on a farm, and combining all that together to make that process more efficient, I think there's a ton of benefit right there. And a lot of companies are, going down that road. But I think agriculture is a really interesting area for this.
Tony?
Yeah, I see. I think two major use cases. I see a lot of this coming together. One is more around I'll call it the industrial manufacturing world. A lot of experience there, and that's whether from doing robotics optimization. Instead of doing this move like this, which traditionally an engineer would just program the moves. Now could run through, simulate millions of different combinations. Say, hey, here's the best. I shaved 3 seconds off of it by doing it this way. So things like that help. Personally, I remember another areas where it really helps is in these factory environments, people like tracking people and using AI for like video analytics and stuff like that. Tracking people in the factory, real life scenario. I remember I was working on a machine, whatever, and basically it would shut down. They kept saying, we don't know why, but we're losing productivity every day around 2 o'clock. They had the data, but that's all. They had no idea. So they ran the video analytics on it, and sure enough, what they found is they had a mandatory break like at 2 o'clock. So at 1:50 every day, the guys hit the e-stop button to get an extra 10 minutes. It took like on start up, so they got an extra 30-minute break. And so things like that, they found out through video analytics really quickly. They're like, oh my gosh, this is what's really going on here. So it's really about mapping the real world to that. The other big use case we see a lot of working with is in basically like smart cities, ITS, intelligent transportation. Tracking everyone else drives city streets, and then we always go, why aren't these lights timed? Because it's very much done manually still today. So by doing that, we could have real life thing, look at cameras, look at people, pedestrians walking, cars coming, and actually have lights and everything track it, a lot better, which reduces, cars on the road, it helps efficiency, it helps with all these things. And so I see this coming today, and cities are starting to do that today. So
Interesting. David or Duncan, any thoughts here?
Yeah, I think most excites me about the digital twin is it's kind of its biggest use, I think, is going to be around personalized healthcare. And the nature of what you're trying to simulate to change a surgical intervention or to try out a drug on someone, something like that, you're going to need to run through scenarios to simulate those scenarios in quite some depth. And so obviously you've got AI could be helping to filter the noisy data that's coming in from what's been recorded of you. And then the HPC itself can be running the simulations. About a decade ago, I was working with UCL, University College London, and they were doing MRI scans and then doing lattice-Boltzmann method CFD modeling to basically work on aneurysms and figure out whether it was something that they should do a surgical intervention on. What's the pressure that would cause an aneurysm to burst? Is this dangerous? Or should we not do the operation? Because actually that in itself is quite dangerous. Yeah. And at that point, 10 years ago, you would have needed to have used the biggest machine in the UK to have delivered a result in a meaningful or a clinically relevant time frame. Mm-hmm. And where we are today, you've got 10x the compute power, a lot more of it available on tap. And I think, those simulations are still there, still need to be complicated. It has to be good HPC going and simulating multiple different scenarios to say, is that the right thing to do? Or is this drug going to work on that person?
Yeah.
We're in the early days of that, and that really excites me.
Yeah, that's interesting. Duncan, what are you seeing on?
I think the interesting part for me is really kind of all of the data that's been collected already that hasn't really been analyzed at the depth that we're capable of doing today. It's really the case of, do we use those machine learning techniques to take a look at the data and essentially do some back testing on it? Are there things that we assumed at that point that we can actually realize, okay, we made mistakes, we can actually improve the algorithm, we can improve the simulation to go ahead and kind of not just take data that we're collecting today, take, the legacy data and do something interesting with that as well.
Yeah, I think getting insights from data that's been sitting around. I have customers that tell us, hey, we have so much data, can't delete it because it might be valuable, but we don't know how to leverage it because we don't know the context of the data that we have, right? Let's close out with your recommendations, right? So as companies are navigating cloud and thinking about digital twin and leveraging that within their organizations, what advice do you have on how to approach it? Maybe we start with you, Duncan.
I think in terms of advice, it's really a case of, what is the outcome that you're looking for? I think so often, folks are able to gather data and sometimes the data leads them astray as opposed to thinking critically as to what is the actual problem. Sometimes, the data early on can lead you in some directions and, kind of always remember to take the broad focus and make sure you target in those directions.
I was going to say something very similar. It's like you've got to start with a problem you really want to solve, and you can't have a digital twin of absolutely everything, otherwise it's just it's too much. Not every blade of grass growing in a field, But there are some things which is hugely important, like the globe with the weather and tornadoes and those things you need to model, or personal healthcare. So you've got to start with a big problem, important problem. And then how to do it? Gosh, I don't know. It kind of depend. But is this where we say 1-800-Rescale, right?
He earned his tip.
There you go. Yeah, let's chat later.
I agree with you two both. I was going to say something about the business outcome, what you're trying to do to start with. But one thing I see a lot about with any kind of digital twin or any kind of these workloads, especially with AI related, AI is always going to be near where the data's located. So that may be the cloud, that may be on-prem, that may be there, and you might have multiple sources of data. So you're going to have this AI living everywhere is what's going to be happening. So having this AI everywhere, it's basically the key to it we look at is we talk a lot about sustainable AI. We don't want to run, nuclear computers basically just to power every little AI out here. We want about right-sized compute. So use the right amount of compute at the right location to make sustainable AI. So I say basically, it's AI is going to be where it's at, but also start planning around, hey, how do I do this in a responsible way, environmental way too? So
makes sense.
Sustainability.
Ian, why don't you close us out with the NVIDIA perspective on this?
One thing I've seen since joining NVIDIA and probably from some of the other kind of sort of Silicon Valley companies is sometimes you just don't know what the right strategy is and what to do. And the key is just to get on with it. Just do it. Like, you're never going to know what exactly is going to be the right digital twin strategy for you. And there's probably going to be some dead ends you're going to go down and realize that's not the right approach. But the key is just to get on with it. Like, you'll never be able to build this like plan over a 5-year plan of what your digital twin strategy is going to be.
Yeah.
Actually, at NVIDIA, I don't think there is a 5-year plan. Like, you just got to get on with it and then iterate and see how it goes and make changes based on what you discover.
Makes sense. Get started, iterate, but keep your end goal in mind, right?
Yeah.
So that was just for Yid's comment, or we're saying thank you to everybody. All right, let's give a round of applause for our panelists. Thank you.
Thank you.